Dr. Kumari. So she is going to talk on bacteriocin and what role of gut bacteriome in obesity management by regulating lipogenesis in toast. She is working at Miranda House, University of Delhi, New Delhi. Dr. Kumari, please.
Thank you, Professor Singh, and good evening, everyone. And I'm thankful to the audience who is still kept awake and is getting late. I'm sorry I will not take much time. Dr. Badri has already made my job really easy because I'm also going to talk something about obesity and aging of the adipose tissue. So before I get into bacteriocins and about talking what is their role in the obesity and how we can use them, I will talk about its background first, a little bit. So let's talk about the gut microbiome. Gut microbiome, I'm sure all of us know. It is a very complex and dynamic microbial community which is, which encompasses almost 39 trillion microbial cells and has bacteria, viruses, and fungi. And they live in the host in a very collaborative way, and they impact the host physiologies in many ways. The gut microbiome can vary depending on the host, genetics, its diet, its ethnicity, geographical location, and even on the mode of birth. There are many, because the gut microbiome is so much involved with the host physiologies, there is a lot of interaction between the host cells and the microbes. There are a lot of diseases which are directly or indirectly being influenced by the gut microbiome. These diseases, they are systematic diseases like you have immune system disorders, you have metabolic disorders like obesity, and then we have insulin resistance, etc. Even the cognitive disorders have been connected well in the last 1 decade with the healthy and non-healthy gut. I'm sure we all are aware of the gut-brain axis, and this is a very commonly used word these days, and we all can connect our roots with a healthy or non-healthy gut. Now, what is the difference between a dysbiotic, or you can say the perturbed gut microbiome, which the states we call it as the dysbiosis? The normal gut is having a very rich microbial diversity, and it has an intact intestinal mucosa. There are no inflammation, and the colonization resistance is exerted by the commensals living in the gut. Whereas in a dysbiotic gut, the diversity is imbalanced. There is erosion of intestinal mucosa, and the inflammation is seen, whereas pathogen invasion can take place because of the breakage in the intestinal barrier leakage. We also call this stage as a leaky gut. Now let's talk about the factors which are responsible for this dysbiosis. Generally, these are external as well as internal factors. Both can influence the gut microbiome of any individual. External factors like exposure to heavy metals, pesticides, or even specific food diets which a person is not used to take in a normal diet, and then antibiotics and many other, sometimes even the probiotics which they are taken or their overdose is done, then they can also create an imbalance in the gut microbiome. Intrinsic factors include the secretions from the gastrointestinal tract itself, the release of interleukins and cytokines. There are many other factors including the genetics, and some mutation can also lead to a change in the gut microbiome. Now, how to restore this dysbiotic condition of the gut microbiome and bring back the healthy condition of an individual? There comes again the role of these microbes, and we know them as the probiotics, or we can define them as the live microorganism when they are consumed in adequate amounts and they can confer a health benefit to the host. We call them as probiotics. As we are aware that a lot of probiotic formulations are right now available in the market commercially. There are a lot of formulations which are generally having the common probiotic strains of lactobacillus. Mostly these strains are belonging to the family Lactobacilliaceae, and it has been shown that Lactobacillus acidophilus and Streptococcus thermophilus are they play a very major role in bringing back the gut barrier intact again. Bifidobacterium longum is again it is associated with the ability to prevent IBD or cure IBD condition, and its role in bringing the mucosal layer back to the normal condition is also very well known. The new addition to these formulations is Akkermansia mesophila. Also, the probiotics which we are getting these days commercially available in the market, now they come with the addition of prebiotics. And one of the most commonly used prebiotic these days is fructooligosaccharides. Now, what are the mechanisms? What these probiotic bacteria they employ to bring back the healthy condition of the host? So, they can normalize the gut microbiome, can bring back the balance of the gut microbial diversity, and this can lead to a colonization inhibition, which again prevent the intrusion of the pathogens. They can improve the cell adhesions by improving the tight junctions and mucin production, like from Akkermansia mesophila, modulation of immune system, and production of volatile fatty acids like SCFA, butyrate, etc. Akkermansia is coming as the next gen probiotic. It has been associated with many diseases, and nowadays it is being used as a biotherapeutic agent, and it is shown to lower the abundance in obesity, diabetes, intestinal inflammation, liver diseases, chronic alcohol consumptions, etc., as well as gut barrier function. Also, both Akkermansia mesophila, its alive or partialized form can restore the gut barrier function. It has been seen to that it can also induce the formation, expression of MUC2 and MUC3 genes, which can produce mucin. Then its role recently has been shown in the IBD, obesity, and alcoholic liver diseases. Now, one of the all these gut microbes, they do these health benefit to the host with the help of the metabolites they are producing along with or during the pathways they are involved with the host metabolism, with the host pathways, and they produce a lot of metabolites. But studying all these metabolites in a combinative way in associated studies is not very fruitful. And therefore, nowadays, these single metabolite centric studies are more and more into the what scientists are taking. So one of the metabolite which is now gaining a lot of attention these days is bacteriocins. Now bacteriocins, these are they have a very high potential as for the probiotic application, biotechnological applications, and they can be discovered from their traditional or the novel probiotic strains, either using culturable or computational methods, and they can be used to look for their health impacts in vivo, ex vivo, or in vitro. And they are then treated for their potential, whether they can have some impact on curing a disease conditions or not.
Dr. Rekha, you have 3 minutes to end.
Okay. So bacteriocin, as I said, these are very small peptides. They are generally produced by the bacteria as their own defense mechanism, and they are mild antibacterial. And they have, because of the low toxicity, stability, and low MIC value, they are highly preferred. Their biomedical uses are also common. They are used in the coatings of the catheters, oral tablets, hydrogels, etc. And they have the potential to reduce the development of MDR strains. is already approved as a food preservative. Now, what is the relationship between the SCD1 and adipocyte differentiation? We read about a lot of studies in the past decade that SCD1 is controlling the de novo page fat biogenesis through various pathways, and we also came across studies which were connecting the role of bacteriocins, which can alter the properties of adipocytes, and it has been shown already that the loss of SCD1 potentiate the beige adipocyte differentiation, and SCD1 is put forward as an important metabolic control point, and its inhibition can be of benefit for obesity, diabetes, and other metabolic diseases. And adipocyte differentiation and fat storage require SCD1 expression. So, before I just go into my study, a quick look at the model, which is describing the role of SCD1 in inducing the fat-induced obesity. In the presence of SCD1, because it is the key enzyme which can convert the saturated fatty acids into monounsaturated fatty acids, that it induces the lipogenic genes in ACC, FAC, and leads to obesity. Whereas its inhibition can increase oxidation, reduce the stored glycogen levels, and AMPK can also be induced, and leading to a leanness of the body. Bacteriocin, this is the question we asked in our recent in silico study, that whether the bacteriocins have the potential to inhibit SCD1. So our model says that if SCD1 can be inhibited with the help of these bacteriocins, we can make a formulation comprising these bacteriocins as probiotics to specifically target obesity. So the methodology is simple. We screened the whole gut microbiome. The Human Microbiome Project database was used to screen bacteria which were earlier associated with the obesity condition. We took their genomes and screened them for the presence of the bacteriocins, made their 3D structures and dot them with SCD1 model structure and looked at their results. And this slide is showing just the model structure of SCD1. I'll just quickly go through it because of the time, and these are the predicted 3D structures of the bacteriocins. I'm just showing the top 6 ones which we have further carrying out the studies on. This is a molecular docking, and we did some analysis. This is normal. And then after the docking studies, we chose the first 6 out of 199 to be very precise bacteriocins, and the 6 bacteriocins which showed very high scoring docking results, we chose them for the 100 nanosecond simulation studies, which further confirmed our claim that yes, these bacteriocins can efficiently inhibit SCD1. So carbon was found to be the best scoring bacteriocin with a free energy change of 91.46 minus 91.46. And I will quickly conclude and talk about the future prospect. The gut microbiota plays an important role in the host health. Pre and probiotics are the future for all the treatment regimes, and possibilities of bacteriocins in obesity management is just simply one piece of a complex puzzle that may vary in size depending on the individual and its diet. And the 6 bacteriocins which we have found in our study, producing these strains, these bacterial strains which are producing these bacteriocins, they have the high potential to inhibit SCD1. They can be made into a probiotic formulation to combat obesity. Thank you so much. I'm open to questions.
Thank you, Dr. Rekha, for a nice discussing about bacteriocin and their role in obesity management. If there is any question?
Sorry, I had to go very quick because of the time.
So thank you, Dr. Rekha. Audience will ask.
I would like to thank the organizers, Anju ma'am and Professor Alok Chandra for inviting me and giving me this opportunity. Thank you so much.
Thank you.